Hello, this is Mr. Kinyanola, and I'm going to give you some problems on isosceles, right triangles, also known as 45, 45, 90 triangles. Okay, so here's the best way to do these problems. If you have flashcards, index cards or whatever, put each of these on an index card and study these, okay? And look at them right when you wake up and right before you go to sleep, and then you will become experts at isosceles right triangles, aka also known as 45, 45, 90 triangles. All right, so as you know, that isosceles right triangles are triangles that are isosceles and have a right angle. And in your class, you should have been shown the pattern that if this is x, then this has to be x, duh, because it's isosceles and these two sides are the exact same length. And this side right here, which is the hypotenuse, is whatever the leg is times radical 2. So, for example, if this was 10, this would have to be 10, and this would be 10 radical 2. Okay, so if you didn't know that, now you know it. Highlight it. Okay, so highlight, 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 highlight that. That is super important, but you should have known that already. So I want to give you guys some examples on that you should be putting on flashcards or in your notebooks, but look at these all the time. All right, so here's number one. Now let's zoom in on the first one. This one is pretty basic. So everyone draw a triangle, put the right angle, put the two tick marks right there, showing that it is an isosceles right triangle. And let's just make this side right here x, let's make this side y, and let's make this side right here 7. Okay, so as you know, okay, press pause, and then in your own in your papers, tell me what x and y are. Okay, should only take you like 2 seconds based off of this nice pattern right here. Okay, so x is equal to 7 because it's isosceles, and y is equal to 7 radical 2 because of the pattern. Whatever the leg is, it's the hypotenuse is the leg times radical 2. Look how quick that was. We didn't have to use the Pythagorean theorem. We just know by the pattern. Okay, so this is number 1. All right, make sure you can do number 1 in less than a second. It should take you longer to draw the problem than actually do it. All right, here's number 2. Draw a triangle. Okay, so, and let's make it a right triangle. And another way to show that it's isosceles is that isosceles triangles have base angles. So let's put this right here, that this side is congruent to this side. So its base angles are only found in isosceles triangles. So isosceles right triangle. And let's make this side x, let's make this side y, and let's make this side 11 radical 2. All right, press pause. Write down the answer. Okay, unpause. Okay, so with the pattern, you should just know that these two are exactly the same. You should have the same answer. So x is equal to 11, because the hypotenuse is just the leg. If this is 11, then the hypotenuse is 11 times radical 2. And this is isosceles, so y is equal to the exact same thing. So 11, 11, 11 radical 2. If you look at number 1, 7, 7, 7 radical 2. If you look at the pattern, x, x, x radical 2. So it follows the pattern. All right, here's number 3. Okay, these are going to get progressively challenging. So that's okay. Look, we did the first two. I think you did okay on those. Just follow the pattern. All right. So everyone draw. Everyone. I'm saying I'm talking like I'm talking to like a million people. It's probably just you're just watching this by yourself, unless you're watching this with your family, which is kind of cool. Watch it with your family. Okay, make this a right angle. And another way to show that this is an isosceles right triangle is let's put a 45 here. 45 degrees. Because if we did triangle sum theorem, we would know 90 plus 45 plus this would also have to be 45, and these two angles are the same. So if these two angles are the same, they're base angles. Base angles are found in isosceles triangles. So this is an isosceles right triangle, or 45, 45, 90. But anyways, that wasn't the question. The question is, let's make this x, let's make this one y, and let's make this leg right here 5 radical 2. Press pause, figure it out, and then unpause it. Okay, unpause. So we know that these two sides are congruent because it's isosceles. So x is equal to 5 radical 2. Now, here's the tricky part. Y. What side is y? It's the hypotenuse. What is the hypotenuse multiplied by? Radical 2. So we're going to write y is equal to, we're going to take the leg. We're going to write 5 radical 2. And we're going to multiply this by what? Radical 2. Okay, just like over here in the pattern. We take the leg and we multiply it by radical 2. In this triangle, what's the leg? 5 radical 2. And we're going to multiply it by radical 2. Okay? So, you just multiply it by another radical 2, because that's what we do with hypotenuses. And let's simplify it. This isn't our final answer. Let's simplify it. What's radical 2 times radical 2? Radical 4. So it's 5 times radical 4. Square root of 4 is 2, so it's 5 times 2. And 5 times 2 is 10. So y is equal to 10. The two legs are 5 radical 2, 5 radical 2. Okay, stare at it. Look at these three answers. Okay, look how they're related. Okay, 5 radical 2, 10, 5, 10, 5 radical 2, 10. Okay, that'll help you in this next problem. So let's write number 4. Number 4, if this is going too fast, just rewind it, okay? Or write a question down and ask someone. So here's number 4. This one's going to be a little more challenging. Okay. But as we do more of these will get much easier if you practice. And you won't have to use the Pythagorean theorem. You won't have to grab your calculator. You can just look at it and say, look, I know what the answer is without even doing any, like, I could just do it in my head. Mental math it. Mental math geometry. Okay, so let's say that this is x. Let's say that this is y. And let's say that this side right here is 14. Just 14. Okay. There are a few ways to do this, and I'm going to move this up. Okay. There are a few ways to do this. And I'm going to grab another pen because we got to use a fancy pen. The fancy pen for this fancy problem. Okay, so let's do this fancy. Okay, so if you remember the pattern, x hypotenuse is x times radical 2, the leg times radical 2 to get the hypotenuse. So what we're going to do is, okay, I'm going to show you a couple different ways to do this. First way is, well, we know that hypotenuse is x times radical 2. So we're going to set the hypotenuse equal to x radical 2. And our goal is to get x by itself. So this is the first way to do it. And this is the mathematical way. So just pay attention or follow along. We want to get x by itself. How do we get x by itself? We're going to divide both sides by radical 2. Okay, So now x is by itself. I'm going to rewrite it over here. And I'm going to flip it. X is equal to 14 over radical 2. Okay. Now, if you remember, one of the rules of math is you can't have a radical or a square root in the denominator, the bottom part of the fraction. So we want to get rid of this. The way to get rid of this is we're going to multiply this by 1, but a weird looking one. We're going to multiply it by radical 2 over radical 2 because you're dividing it by the same thing. But why is that helpful? Okay, so it's helpful because 14 times radical 2 is 14 radical 2. Radical 2 times radical 2 is radical 4. Radical 4 is just 2. Okay, and if we simplify that, 14 divided by 2 is 7 radical 2. My fancy pen isn't working right now, okay? It's running out of ink. Okay, so x is by itself, so x is equal to 7 radical 2. And if x equals 7 radical 2 and these two are isosceles, so y is equal to 7 radical 2. Okay, so that's the first way to get this fancy problem. Okay, the second way is this. Okay, second way is, well, we know that the hypotenuse is 14 and it's equal to x radical 2. Let's separate this. I want to figure out what times radical 2 is equal to 14. And whatever's in here would be my legs. Okay, because remember the hypotenuse is the leg times radical 2. So if I could figure out what times radical 2 is equal to 14. Well, 7 times radical 2 doesn't equal 14. That's just 7 radical 2. But what if I put 7 radical 2 times radical 2? Does that equal 14? Radical 2 times radical 2 is radical 4. Radical 4 is 2. Let's write that down. Which is 2, which is equal to 14. So this right here is our x. Because this whole thing right here is a different way of writing the hypotenuse. Because this is equal to 14. We want to ignore that radical 2, that extra radical 2, and this would be our answer, just how we got here. Okay, kind of like how we did this problem number 2. If we ignore that radical 2, that would be our legs, 11 and 11. If we rewrote this 14 as 7 radical 2, and just ignore that radical 2, we would have our answer, 7 radical 2 and 7 radical 2. Okay, if that was too much, if this was too much, another shortcut to this is this. Let's look at number 3. Look how these two are related. And this is just a quick shortcut, okay? If the hypotenuse is a whole number, like 10, okay, look how these two are related. The leg is just the hypotenuse, half of the hypotenuse times radical 2. Okay, so half of 10 is 5 radical 2. Y is 5 radical 2. Or, yeah, x is 5 radical 2. Let's look at this. The hypotenuse is 14. So to get the two legs, just divide 14 by 2 and multiply it by radical 2. Half of 14 is 7 times radical 2. 7 radical 2. So that's the shortcut. So I showed you 3 ways. Hopefully one of those 3 ways works, but the shortcut is if your hypotenuse is a whole number, just divide it in half and multiply it by radical 2. Okay? If your hypotenuse is 11 radical 2, if your hypotenuse is something times radical 2, just ignore it, and then that would be your 2. Okay? All right, so that's the difference between these two problems. If your hypotenuse is a whole number, divide it by 2 and multiply it by radical 2. If your hypotenuse is a number times radical 2, ignore it, and then there are your 2 legs. Okay? So look these 4 over. I'm going to show you a couple more. Here's number 5. Oops. All right, number 5. Draw this. Draw this. Draw this. And let's put some base angles so that we know it's isosceles, right? And let's put 5 radical 7, and let's put x, and let's put y. Okay, press pause. Try to figure it out on your own. Okay, unpause. X is the same as its leg because it's isosceles, so x is equal to 5 radical 7. Y is the hypotenuse. So again, the hypotenuse, the pattern. You take the leg and you multiply it by radical 2. Remember? Leg, 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 radical 2 for the hypotenuse. And let's multiply these two. 5 and radical 7 times radical 2 is radical 14. And that's it. Y is equal to 5 radical 14. X is equal to 5 radical 7. All right. And number 6. Now, this may look like the same problem or a very similar problem, but don't be fooled. And you're not a fool, so don't be fooled. Okay, so let's make this side 5 radical 6. Okay, and let's make this x, and let's make this y. All right. Press pause, do it, see what you got. Unpause. Okay, x is the same as the leg, the other leg, because it's isosceles, so x is equal to 5 radical 6. Easy peasy. Y is the leg, 5 radical 6 times radical 2, because it's the hypotenuse. Hypotenuse is always multiplied by radical 2, no matter what. Even if it already has a radical 2, multiply it by another radical 2. This one, it's multiplied by radical 6, so multiply by radical 2. Okay, always multiply whatever the leg is times radical 2. Now let's simplify this. Radical 6 times radical 2 is radical 12. And you may be tempted to box this confidently and say, I'm confident this is my final answer. However, this is not the most simplified answer. You want the most simplified answer. So how do we simplify this? You guys know how to do square roots. Let's factor tree it. What are two numbers that multiply 12? Let's try 4 and 3, and let's do 2 and 2. We found a pair. Pairs go on the outside. So radical 12 is simplified as 2 radical 3, and this 5 is still there, so times 5. So instead of radical 12, we simplified it as 2 radical 3, and we brought down that 5. 5 times 2 is 10 radical 3. And this is your final answer. Okay? These are a little challenging, but I think you guys are getting this. I hope you're getting this. Okay? And here's the last one. So make your right triangle, isosceles right triangle. And let's make this x, let's make this y, let's make this 7 radical 11. What? Radical 11? There's no radical 2 in there. Okay, well, how do we do this? Okay, well, let's look back at what we did with number 4. The first way we did it was we took this and we did that and we divided by radical 2. So let's do that. Okay, so let's put 7 radical 11 is equal to x times radical 2. And let's get x by itself so we can get the leg. So we'll divide both sides by radical 2. And we don't have to do anything fancy with this. We can just divide. What's square root of 11 divided by square root of 2 is just square root of 5.5. And that's it. Equals x. X is equal to 7 times square root of 5.5. And because these two are congruent, it's isosceles. Y is also equal to 7 square roots or radical 5.5. So here are your two answers. All right. Hopefully this helps, and I hope you guys look at all of these, all 7 of these different types of problems. Use a pattern. Remember, hypotenuse is always whatever the leg is times radical 2. Okay. Especially look at numbers 2 and 4, see how they're different. And look at 3 and 4, how they're related. And the more you look at these, the easier it'll get, and the quicker that you'll be able to do these. All right, so yeah, here are the shortcuts for isosceles right triangles. Look at these right when you wake up in the morning, and look at these right when you go to sleep at night. And go over these with your mom and dad and say, hey, mom and dad, let's do these together. It's fun. All right, have a great day.